So what the topic for today's this particular session, lecture 6, was overall leveraging emerging data systems as they relate to safety, what are technologies, and how do we tie them together. So based on this, later on today we will work on one during the tutorial to tie elements of data that I shared with you an Excel file yesterday. We had 3 sheets in there, but I only made you work with 1 sheet. We will see how to link, you will see how to link the data in the multiple sheets. So this is something I told you earlier, that I will show you a graphic that talks about what might be the outcomes or probability of survival if a motor vehicle strikes a pedestrian at various speeds. You may have seen different variations of this. At the top you have a motor vehicle at 30 kilometers an hour. If it strikes a pedestrian, there is a 90% chance of survival. In the middle, it is 50 kilometers an hour is the travel speed. Now the probability of survival drops from 90 to 60. However, when you double the speed from 30 kilometers an hour to 60 kilometers an hour, the probability of survival drops from 90% to just 20%. So this goes back to designing roads, posting the speed limits that are appropriate to the conditions there. Here is another way of looking at it, is by the type of vehicle that might impact a pedestrian. The probability of death is what is given, and I believe this is for a 30 kilometer an hour impact. So the larger the vehicle, lower is the likelihood of survival, or higher is the probability of death. So that is the other message from here. One other term that I used yesterday, I know several of you were writing this MUCC, MMUCC. I wanted to put it in writing here. It is the Model Minimum Uniform Crash Criteria. What it is, I described that to you yesterday, but I just wanted you to see it in writing what that is about. So the question I have for you is, from a life cycle, transportation system decision making from a life cycle perspective. That is, life cycle is from conception, when somebody thinks of it, till you build it and you maintain it, you operate it, and you may have to rehabilitate it. So from conception, inception, and maybe there are some facilities that you will get rid of, but most of our transport facilities go on and on if you properly maintain and update them as necessary. So that is the system life cycle, but at every stage we need to take into account safety. Every step of the way. You can't sit by yourself, you know that, Shashi. So every step, it is not that you introduce safety afterwards. Right from the policy stage, even during maintenance. Maintenance, think about not the safety, you know the construction zones or work zones, safety. We think maybe mostly as users of the roadway, road users. Aage aa jaiye, akela mat baithna. First row. And so think about the maintenance workers. Their safety is also important. These are some of the photos from the crash that I described to you yesterday, the sad thing. Every crash is sad. Why am I not advancing? So safety, make safety personal. What we are trying to do is modify behaviors. This is a fairly busy chart. This shows, but you get the sense of it. These are pedestrian crashes in the Las Vegas metropolitan area. The distance from east to west, or I should use the pointer. The east to west distance is about 40 kilometers. North to south is about 55 kilometers. So you get the sense. And the darker the shade means higher the concentration of pedestrian crashes. So this just to show you that there are problems, but what I am getting at is the message, is we need to make safety personal. What we are trying to do is bring about changes in behavior. These are the most difficult things for us to do. Changing human mind, human behavior is very challenging. So, what are sub-elements of these? There are attitudes, there are beliefs, there are perceptions, and some based upon experiences, some based upon, oh, somebody told me this is the right way to do. I don't need to wear seat belt if I'm sitting in the back of a car because it's not required by law, or so and so told me that it's not needed. But we have to map that as what is reality, help people understand that. Only then will we be able to effect behavioral changes. So, this the next one. So, what we need is a value proposition. We need to make it, when I said safety is personal, what value does it bring to you, to you, to you, to you, to me, and to us as individuals and collectively? If there is a value that they see, then they are more likely to pay attention and do something about it. If there is no value, they are not likely to buy into that. Why should I do that? It does not bother me, does not affect me, I don't benefit from it. So, a lot of it is mujhko kya hai isme? Make it personal. So, this is a quote that my daughter wrote, my older daughter wrote me. I think she was 5 or 6 years old when she wrote this. We were talking about something, then next day I see a little handwritten thing, my mind is my own. Okay. You can tell me things, but I make up my own mind. I've carried that. Okay. And it is one of the most difficult things for us to change, the human mind or human behavior, human thinking. How can we bring about change? I could lecture to you today, tomorrow, next day, the whole year and say this is what is to do. Chances are that I may have a little bit of an impact, not more. But who else can help make the impact? Peer pressure, society. We talked about various groups, faith leaders yesterday, religious groups. They have a lot of things. But usually the peers have a tremendous amount of effect. And children on their grandparents, not necessarily children on their parents, children, grandparents, that's skip one generation, that seems to have a thing. Is there any economic or personal? What does it mean in terms of my personal financial situation? Will it make a difference? Then they may pay more attention. So, this is the phrase I used yesterday. I adopted a philosophy over the years, is catch 'em early, hook 'em young. This is American slang for EM is them. Okay. And I told you I borrowed it from the tobacco industry. You create a habit when somebody is very young, it carries on for the rest of their life. The tobacco industry has done a fantastic job over the last 150 plus years, getting somebody to use, whether it is a BD at a 10-year-old or so, maybe 1 puff, 2 puffs, or Zarda, whatever be that. And it is very difficult to break that habit. So, same way, if we can have children in elementary schools, middle school, or when they begin to drive, start with good habits, not bad habits. That will carry on for life. Yes, it's possible that good habits may change a little, but at least the foundation is there if you want to find a way to come back to that. So, these are habits. So, I told you about. And in India, the example I use is we can change habits, we can change behaviors. Some of you may be a bit too young, but I know at least a few of you may realize. I saw when I came into the IIT campus, no use of tobacco on campus, right? No smoking, no nothing. It was fairly common when I was growing up and even into when I was in college and so on. People smoked all over the place, on campus, away from campus, in buses, in cars, so on and so forth. But I think, I don't know when it started, Akhilesh, you may be able to help me. But in the last about maybe from 2015 or thereabout, I see smoking is ostracized. People will say, don't do that. Somewhere between 2010 and 2015, and the transition occurred, I think, in a 5 to 10 year time frame. And one very specific personal example I have is, I mentioned to all of you that my home is in a little village. And one day I took the bus to go to the near junction that's about 8 kilometers away to do for some transactions. Went to the store, bought a few things. And coming back, I got into the bus, and the bus at the junction, it waits for 5 or 10 minutes to get passengers, so on. And as I was sitting there, next to me there was another passenger. In front of us there was a passenger. And the passenger in front lit up a cigarette and started smoking. So the person next to me just tapped him on the shoulder, said, no smoking in the bus. Don't you know that? No. So that's social pressure, peer pressure. So if in India we could bring about the acceptance that it is not healthy, not good for you and for others around you to smoke, we were able to do that in about 10 years. I shouldn't say we, I did nothing. I don't want to take credit for that. Whoever was involved got it done in less than 10 years. Why can't we then get small behaviors such as wear a seat belt every time you're in a car, whether you're in the front or you're in the back seat? As long as there is a seat belt, wear the seat belt. Why cannot we do that? I don't know what were the tactics, the techniques, methods used to bring about this tobacco use change. That's something for you all to explore and see, hey, can we do that? So I'll come back to safety now. How would you characterize safety? What should be the priority of safety? I'm going to have you all talk. I see 3 groups here, 3 groups of 3, and we have 10 people online. So if you can get together with your WhatsApp groups, I will give you 1 minute and take into account everything that you have in our lives on a daily basis, what we do or what we try to influence. And safety is one of those. As far as priority is concerned, how would you prioritize safety compared to everything else? When I say everything else, I'm going to look at transport. Okay, I want to get from here to the airport. I have a flight to get to, I have to go to the railway station, or I have to go pick up my child from school, or I have to go do the shopping. Number of activities, things that you do. Maybe you are a design engineer, maybe you are a construction manager, maybe you are a planner. So think of different roles in the transport domain. What would be your priority for safety? There are a number of factors you need to take into account. I will give you 1 minute starting now. Talk to your teammates. Five seconds to go. Time's up. Now stop talking. Until now you had a chance to talk. Okay, WhatsApp group 1, I just want you to, in 2 or 3 words, I don't want you to say my WhatsApp group did this, 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 this. Just tell me, how do you prioritize safety? WhatsApp group 1. I don't see or hear anyone from WhatsApp group 1. WhatsApp group 2.
WhatsApp group
Yes,
1.
this is Ashwini Gupta from WhatsApp group 2. So I would say that for me to reach a place on time, so that was my first priority. Second priority is safety, and third is cost.
Okay, thank you. Once again, I'm going to correct Ashwini. I don't want you to say this thing. Just say my top priority is time, second is safety, third is cost. Okay? So now here, the group on the far right, for my right. Please identify yourself so that people online can know who's speaking.
Yeah, Sashi, right. So we are Sashi, Ashagri, and Ritik. For us, it was the continuity of the machines.
Continuity of the machines?
Yes.
Expand on that. How would you where does safety come in that as a priority?
Don't take your vehicle for granted.
Don't take your vehicle for granted. Okay. WhatsApp group 3.
Sir, safety first, second time, and third is cost.
Safety, time, and cost. Okay. The group in the back here. Introduce yourself and the team.
So myself Daniel Dole with my team Ritesh and Isita. So in safety we have to think twice before any cause of actions. Suppose we are crossing any road sections. then we have to think twice before to think about
twice
safety.
about safety.
Yes,
okay,
sir.
but in terms of priority,
Yes,
with
sir.
the other factors we talked about,
Sir,
where would
it's
you
also
put it?
it's better to let to become late. Also one measures.
Better to be late. Okay.
Yes.
There is when I was in college, there were signs in terms of promoting safety on the college campus. It is better to be late than the late. Okay. All right, WhatsApp group 4.
Hello,
Yes, Shruti.
I'm Shruti from WhatsApp 4. Our priority is also, it's basically time, it should be safety, time and other things, but normally it is time is given more priority than safety
Okay.
at times.
Thank you, Shruti. Who are your teammates?
Pratyush, sir, Pratyush, I don't know anyone else.
Okay, Pratyush. Okay, thank you. So the group up here in the classroom.
Sir, my name is Rahul Narayan. I am with Sanatan Das and Rizidu. Sir, if we talk about human behavior, so I can connect human behavior with our accountability.
No, I just want you to tell me where safety is in your list of priorities.
Yes, sir. Accountability.
Accountability is the top priority.
Yes,
okay.
sir.
Second.
In our surroundings. Second, the vehicle safety.
Okay.
And third is the road infrastructure.
Okay.
Yes.
Thank you. Thank you. WhatsApp group 5.
Hello, sir. Good morning. Good morning, all of you.
Good morning.
Chandrika here, and my teammates are Mr. Abbas and Miss Aswarya.
Okay.
Yeah. So regarding the safety concern, safety is a personal, but sometimes other causes problem on the roads. But we always keep in mind everyone has equal right to commute on the road same time. So we must respect everyone's right while we are traveling on the roads.
Okay, so where does that put safety as a priority?
Yeah, safety must be on priority. That's why we can't harm while we are traveling on the roads. We have in keep in mind. Yeah.
All right, thank you. WhatsApp group 1. Is there anybody from group 1?
Yes, sir.
Yes.
This is Tazim.
Yes, Tazim.
It was a question for me to pose yesterday. I was about to ask this. Among these two priorities, what should we do the priority? To me, I think travel time is more likely influential than safety, then comes the safety.
Okay.
As per the conditions which are we facing in heterogeneous conditions.
Okay, thank you. Did you have anybody else on your team, Tazim?
Yeah, there were some members, but I don't know them as such.
Okay, all right, good. So I appreciate your thinking about it. I mentioned earlier, I think it was yesterday or maybe the first day, when each of us sets out on a trip, we as individuals, or if we are traveling in a group, are setting out on that trip with the expectation that we will safely reach our destination. Nobody is setting out on a trip thinking that it's 80% chance that I will get there safely, or 90% or 99%. We are all 100. Our families, our companies, if you're traveling on work, or your employers, your friends, everybody, maybe you're going to visit somebody, they're expecting you to get there safely. So each of us individually and collectively expects safety. It's not a compromise, right? I'll get back to that. I should have pointed out, so this is a children's book, Fox in the Socks. Dr. Seuss is a very popular author of children's books. So you will see he comes up with books, very small books, maybe there are 8 pages, 10 pages, cardboard, which young children cannot tear it, okay? And rhyming words, so that's where Fox in the Socks and so on. I was just saying that to tie it to my daughter. Yeah. So now I want you to pay very, very close attention. I'm going to tell you that safety is not a priority in what I do. I'm repeating. Safety should not be a priority in what you do. What can you do with priorities? You can move them up, move them down. Safety must be a core value. A core value is something that you cannot take away. It is embedded like the fabric of the clothes that we wear. So, do not compromise on safety as a priority, regardless of, oh, the chief engineer says, hey, we need to get this done in 2 days, we cannot. No, if it is going to compromise safety, whether the worker's safety, the traveler's safety, whosoever, you should not compromise on that. So, do not look at safety as a priority, one of the variables or factors that you can rank up or down. It is a core value. Many of you said that safety of you, safety of the people around you, but a few of you said travel time, oh, I need to get to my destination on time. There is a common thing that I hear about the traffic and people's attitude towards time in India. Everybody on the road is in a rush to get wherever it is, but no meeting starts on time. Even today's session here. If we are all in a rush to get there on time, then why are we not having activities start on time? That's, I digress. So, safety is a core value, it is not a priority. So, how do we go about developing safety strategies? I have touched upon this earlier, so I will move through it quickly. Quantitative is what we have talked about quite a bit in the last 2 days. Qualitative, I touched upon that, is anecdotal, especially where you do not have good records, documented records on paper or electronically. You talk to people who have experienced this either in the neighborhood, or it may be a PWD officer in a field office who covers one district or some area there. That person may know something has happened there. Shop owners, they see lots of things happening, workers in the shop. So, we need to look at data to identify risk, then how do we mitigate risk. So, that is where you might have heard the term countermeasures, or what do you do? Interventions. It could be engineering, enforcement, education, emergency medicine. We have talked about many of that. It is very easy, or I should say it is easier for us to dream up, to come up, to plan, to design the countermeasures, but implementation, translating it from theory, from concept, from plans to actual use of is the big challenge. Professor Maurya showed 2 days ago, very well thought of, okay, you have the median barriers and pedestrians should cross in a zebra crossing, and they put the zebra crossing right where in the middle of the median barrier, right. So, the minor thing, sometimes it is very minor, but many times it is that the intervention is not accepted by the users. Who are the users? Basically the road users. Sometimes it is the community, maybe it is the business owners on the side of the road. If you say no parking this zone because you do not have line of sight, sight distance is not available, we want to eliminate parking here for motor vehicles, maybe two-wheelers can park here. There could be some business owners who say no, 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 you are taking away my business, because if people cannot park in front of my store or my business, I am going to lose business. So, how do we get that buy-in? Sometimes it is something that may be technically feasible, but money wise, financially infeasible, cost too much, we do not have that budget to do what would be the best thing here. So, we need to work with the stakeholders and education and outreach before you come up with your final countermeasures. As you develop the countermeasures, as you are in the thinking planning stage, engage key people who, especially those who you think are going to be the strongest opposition. If you can win over the strongest opposition, it is a piece of cake to get the others, or if you can at least address their concerns, make them feel heard. So, these are examples that we have talked about. This is a traffic safety pyramid in terms of the events. What we have here at the very top are the crashes. At the bottom are undisturbed passages, basically trips. So, you have many trips for which you may have a few potential, smaller number of potential conflicts, even smaller number of slight conflicts, more serious conflicts, but at the very tip are the crashes, and that crashes I have zoomed in here, which is on the Capco scale, fatal, ABC, injury and property damage. So, in terms of severity of adverse outcome from the bottom of the pyramid to the top of the pyramid is it is getting from more and more severe. Relevance to safety, well, if you have an undisturbed passage, chances are that it does not have any direct bearing on safety, but somewhere around here potential conflicts, serious conflicts, can we learn from them, because you may have had a conflict, somehow they avoided it. So if we can understand what were those triggers or causal factors that led to this, we may be able to learn from that, but at the top it is extremely relevant. So the orders of magnitude of data for this, typically in a year we have trillions of trips and miles or kilometers of travel. So that is 10 raised to the power of 12. We have billions of imminent collisions, trajectories that could possibly collide, but the users took some action to avoid it. We have hundreds of millions of crashes. These are US data, okay, I think from 2021 or 2022. So that is 10 power 8. So 10 power 12 to 10 power 9 to 10 power 8. We have tens of millions of crashes every year. In the US it is nominally around 13 million crashes over the last decade if you look at it per year, 13. A vast majority of them are PDO crashes. So there are about 2 million injuries. So now you are getting to 10 power 6. And remember I told you we have about 43,000 fatalities. So that is 10 power 4. So you can see the exponential. This is what I had told you in words. I just wanted to put it in numbers to give you a context, and that relates to the pyramid that we have here. So how can we learn from what we have about these imminent collisions? If we have billions of collisions, even if we can get a subset of that, 1/10 of 1% of that, you are looking at millions of events. And with today's technologies where we can process gobs and gobs, lots and lots and lots of data very quickly, we can integrate data very quickly. We will talk more about that in the later today. We can learn from that to try and see what might have been causes for this near collision, or how did they avoid the imminent collision. And most of this is inferential, not observational. When we are looking at data and saying, okay, this must have been what happened, when we are discerning why something didn't happen. Or if you have video streams, you can look at what happened. Okay. So you have the stated preference versus revealed preference theories in transport planning. So this is much more of what we are looking at is revealed behavior. We are looking at behaviors, not saying, okay, what did somebody say they will do. So when we look at data, I alluded to this, we start with data, translate that to information, how do we derive knowledge from that, and then move on to decision support. And there for transportation safety related data, what we are looking at is the sources, how we analyze them, and how do we use that for management. The emerging fields are, you may have heard of CAV, connected automated vehicles. I use the word CAVIS, the IS is for infrastructure systems, because we have sensors that are on the road, along the road, around the road, that we can use to tie to the road users, the road itself. Sometimes it's the road health that we want, especially where you have snow or ice conditions or high wind conditions, to be able to get that information about that gives you some information about the health of the infrastructure. Other sensors may be, okay, the bridge, do you have cracks, so on and so forth. But here we are not looking at bridge design, but looking at safety from a road user perspective. The other one I say is ACES, automated connected electric and shared systems. So all of these leverage sensor data. Here's an example of a sensor data video feed in the Las Vegas metro area. This is from one of the companies that we partner with. What you're looking at here is actually the trajectory of pedestrians, and in the US we drive on the other side of the road. So a right turn there is a free turn, like a left turn here is, but we are able to discern the projected trajectories. And what you see a lot of detail here that you cannot read, I just wanted to let you know. Key things that we are looking at is there a potential, based upon the speeds that we have observed, are these trajectories likely to collide? If they are to collide, we call time to collision, TTC. or if it is a red light violation, we call it post encroachment, PET, post encroachment time. The signal turned to red at this time, but it was 2 seconds after the signal turned red that they went through. So we can discern such data from some of these emerging sensors, sensor systems, but these are huge. Just like we talked on the previous slide, the pyramid, you are now talking about billions and billions of records. How do you manage them? How do you leverage tools and techniques and technologies? So we need, if you have sensors, you need communication systems that will relay what the sensors are tapping to some place where you can analyze the data. And what tools do you have? Do you want real time, or can you do post process? And how many of you have heard of the term edge computing? Yes, I see some hands. So you don't necessarily need to relay, use telemetry to transfer all the data from the sensor that is on the road, whether it is in a vehicle, in a mobile phone, or on the road sensor, to a central control place. We can process some of the data right within the vicinity. So that may, certain data are amenable to that, others you still want to have it at a centralized place. So when you are looking at trajectories of this sort and want to process the data, the volume of the data are huge in terms of the streaming and the size you need to store the data. So you need to make decisions on, we don't need the data, we get it every second, but such data we just need to condense it maybe once a minute. So instead of 60 readings, you have 1 reading, or once in 10 minutes. I'm just using crude examples. Think about that, and if you have the ability to process, and maybe you store some of it locally if you want to retrieve it later, you're not sending it to them, and you write it over. If nothing happens for 1 hour, you can erase the old data, but if you wanted to reconstruct what something happened, you don't want to write it over. It could be on a 24-hour basis, 1 hour basis, 30-hour basis, 30-minute basis or so. The airplanes have 2 black boxes, they are actually orange boxes. Voice recording, what the cabin crew are speaking, the flight deck crew are speaking, and then you have another recorder that records a whole lot of information about the equipment performance. We have that on vehicles too now, okay, believe it or not. But on airplanes, because they cannot record this for a 5-hour flight, everything is going on, or now you have 17, 18-hour flights. They save it for 30 minutes, and after 30 minutes it's looped over. And can we do the same thing for the traffic data that we are looking at? So there are challenges I talked to you. So data, we've talked about qualitative, quantitative. Many people think we must have data right now. Not necessarily the case. Maybe for traffic signal operations, you need near real-time data about the queues, so on. Maybe some speeds, but for the most part, we do not need near real-time data. When you're looking at the camera feeds and trying to avoid collisions or vehicle-to-vehicle communications on the CAVIS domain, yes, you need real-time data. But for our planning, design purposes, no, we don't need near real-time data. It could even be a year old or 2 years old, or sometimes we look at the last 10 years of data, last 30 years of data. So we have data coming in from multiple sources, and how do we capture the data, integrate the data? I showed you examples of the spatial and temporal variations that we could have in the granularity or the resolution of the data. And once you do that, you go through the QA/QC process. Synthesize is the next step higher, not just the analysis, and communicate the results of the analysis to the intended audiences. Their visualization is a big part of it. So historically, traffic engineers, transportation planners, design engineers have all relied on very, very traditional sources to get these data, traditional methods to look at how to process the data, how to analyze the data, maybe sometimes correlate or link the data very little. There are non-traditional ways. Several examples we had yesterday. Engage, many of you said, look at the neighbors on either side of the road. Look at business people. look at parent-teacher associations, school teachers, faith-based religious leaders, so on. So that's some of the stakeholders. Traditional data used to be, we do surveys, online surveys or intercept surveys. You go stand with the olden days was pad of paper and you ask questions and or maybe a tablet or a computer and do that. They are still valid for some parts, but can we look at sensors, as we had mentioned, use phones or other sensors? Vehicles have embedded tools. Oops, wrong button. So in terms of the role and importance, we have vehicles that operate on users in vehicles that operate on road networks, or users on road networks if it's a pedestrian, there's no vehicle. Soon we are going to have, we already have in some parts of the world, vehicles on networks with no users, autonomous vehicles. So maybe they're going to pick up a ride. But this is the nexus, is users, vehicles, networks. I developed this graphic when I was at the University of Alabama, and we had Mercedes-Benz about 15 kilometers away from our campus. Okay, so that's but we work in an environment where we need to take into account societal expectations, considerations, political considerations, and what I call 7 E's. Many of you alluded to this: economics, money, expediency, time. I want to get there on time, but there are a whole bunch of others: efficiency, energy, environment, equity. Are we being fair to all the users, to the stakeholders? How you may not be able to be fair all over, but reasonable fairness. Equality is not the same as equity. And as I said a few minutes ago when I said safety should be a core value, not a priority, don't compromise on it, that's where our personal ethics come. Our organizational ethics come. When you work for a company, an agency, whoever it is, for yourself, do not compromise on your ethics. People expect that. Your users think that those who are doing this, building the transport facilities, operating the transport facilities, whatever you got to do, are operating in an ethical manner. So do not compromise on your ethics. And so through the life cycle, and what I say is, so we've gone through this policy through rehabilitation, safety, safety, safety. That's in the heart of everything. So if you look at the evolution of data collection, it started with manual, then we had some automation. So olden days, even if we wanted to get traffic counts, there was somebody sitting and counting the vehicles going, or turning movement counts. Even until recently, and I believe even now in many parts of the world, if you want turning movement counts, there's somebody sitting at a corner of the street with a board with left, right, through counter. You keep pushing the buttons. But in the recent past, the recent decade, we have more. 2007 was when the first smartphone came on, when Steve Jobs introduced the first iPhone. But it took about 5 years or so to get great attraction, but in about the last 10 years, it's gained global acceptance and adoption. So if we can rely on smartphones as sensors, the cost is very low for us to gather the data. But there are only certain types of data you can get. You can get location, you can get time, and to some extent we can discern speed, acceleration or deceleration, longitudinal and lateral. But we cannot get information about what was your trip purpose. Whereas if you do an intercept survey, you can ask that. So the types of data you can get are somewhat limited. But for the most part, from a traffic safety operations, planning, design purposes, this is plenty. Oh, this is good, I shouldn't say plenty. We can also discern things from a planning perspective in terms of origin destination patterns. Doesn't have much to do with safety. Where did the trip begin, where did the trip end? And we try to anonymize it by deleting the first kilometer or first half kilometer, last half kilometer, so that you're not pinpointing every single user. General area where they start, the general area. And connected vehicle technologies, you're taking it one step further. But in the last two here, what I have here, smartphone or connected vehicles, there are increasing concerns in two ways. Privacy. Is my data being compromised? Are you tracking me? Fair question. Yesterday I said, yes, if you have automated enforcement, you only need to be worried about if you violate the law, yes, you're on camera. If you don't violate the law, you're not on camera. Whereas when we use smartphones, it's not necessarily an individual phone. I don't know whether it is my phone or Professor Maurya's phone, okay, or Sanathan's phone. We just know that here are 3 phones that are in this facility. Oh, we were walking from here to the dining hall. So we don't know who it is, but we know there are 3 people moving, so we can get that. So usually it's hundreds. I just use this as a small example. So this is a classic old photograph from the 1930s in Europe, where you have dozens of people doing intercept surveys. Maybe, I don't know where the location is, somebody was stopped, or there are government agencies who have the authority to stop traffic to do this. Most road users don't want to be stopped. As many of you said, you want to get from your origin to your destination as quickly as possible. So maybe when somebody's stuck in traffic, that's it. So we've come a long way from there, folks. So what are the data elements that we are interested in? The physical infrastructure, the vehicle characteristics, user characteristics, and the interaction between users, vehicles, and infrastructure systems. That's where the safety comes in, not necessarily any one of these individually. How do we interact? So the graphic that I have up top here is again from one of the traffic intersections. It's Flamingo Road, Maryland Parkway. This is less than half a kilometer from my office. Okay. And you can see this is a city street. You have multiple lanes. You have 2 left turn lanes, 3 through lanes, 1 right turn lane. So this is a city street. It's very busy. And if you keep track of planning, ADT, the average daily traffic here, is something in the order of 55,000 to 60,000 vehicles. So in our urban streets, we have between 30,000 and 70,000 ADT. On many interstate highways in the US, once you move away from the urbanized areas, your ADT is only somewhere in the 20,000 to 30,000, or maybe even lower. Okay. So I just wanted to show you how wide the intersections are, but now we have cameras on all approaches. So this is used from what is called a freeway and arterial system of transportation. They're using this for traffic control to try and see where do you have queues, backups, and do you want to change the traffic signal timing pattern. They don't do it like the police here, stand at a corner and change it, right? It is all centrally controlled. There are over 1,500 traffic signals in the Las Vegas metro area. And there are timing patterns and sensor-based patterns. What they do is, if there is an incident or something that caused a disruption to the travel pattern, then they can take control of one intersection or a series of intersections. And we have many what we call special events, large events in stadia that have seating capacities between 20,000 and 65,000. So when you have people coming in either for a football game, let us say, or how many of you have heard of a singer by name Beyonce? Is there anybody who has heard? So she comes and performs in last people of that ilk. Okay. So you have 65, 70,000 people coming into the show. They're all coming in in a narrow time, maybe over an hour. When they're leaving in 15 minutes to 30 minutes. They all went again. Those are times when such centralized data. But what else are we getting? From our perspective, the camera by itself is not doing the counts. But with today's computer vision tools and techniques, we can get counts of vehicles. You were talking about speeds and trajectories of vehicles, Daniel, yesterday. So we can get the type of vehicles, type of users, pedestrians, bicyclists. But we have to develop the tools. So there are many computer scientists who are developing these tools. So the purpose of the camera was initially for traffic signal control and operations, but we can extract data. You were about to say something, Daniel?
Yes, sir. Yesterday, actually, I discussed about travel time, actually. That was actually, sir, based on FAI, actually. based on API,
APIs,
Google
yeah.
APIs.
And you were also trying to figure out if it is a bus versus a car, right?
Yes, sir. Actually, types of vehicle we can input on that code. Based on that, we can collect.
Yeah. Okay, so that's what we are trying to do. So the intended original purpose was something else. Now, how do we engineer that to get data that is useful to us? So other data elements, I'm going to go quickly over these because I've already touched upon it. The key is how do you tie these together? The driver's licenses, vehicle registration, vehicle insurance, and law enforcement. We talked about repeat violators, warnings, citations or challans, and information that we give to the officers or for officers about the travelers who is in the motor vehicle. And one of the groups that I worked with when I was at the University of Alabama, they also provided the police officer, the law enforcement officer, when they look at the driver's license, they scan the driver's license or swipe the driver's license, tap into the social networks of this person or the social history. Does this person have other criminal records, not just traffic violations? In the US, it is not uncommon for state laws or local laws to permit an individual to carry a firearm, weapon, gun. Okay. So for the police officer's safety, it is important to know, okay, I stop somebody, this first time offender doesn't have anything, maybe it's an okay. Whereas they stop somebody else, and when they look at the profile, this person has several other violent things, or this person has in the social network others who have criminal history. Then the police officer calls for a backup, saying, hey, rather than just continuing the interaction, have somebody else for support. So that's an extreme case of data mining, so to say. And here is the old form of the crash report. But yesterday I shared with you the problem, the one that you worked has a subset of the fields. That comes from the muck, the fields. So olden times it would be all recorded on paper. We converted a lot of that onto electronic, but nowadays most of the agencies, there are companies that provide software. It's click or drop down menus and you identify. So you minimize the time required for data entry, you minimize the potential for errors in data entry. And so adjudication, for what happens when a challan is written, how do the judges, the prosecuting attorneys, defense attorneys work? EMS, a few of you worked on the problem yesterday. When did the event occur? When was it notified? How much time did it take for the responder to get there? So I don't have to harp on that. But there are other things after that first response. What happened to the patient, the person who was injured during in the trauma in the hospital, and were they there for a few hours, a few days, weeks, and what happened after that? And there are costs from the health insurance, healthcare costs. Here are, thanks to Professor Maurya, he sent me a few things. These are examples of challans that he shared with me. This is from, the one on the right is from Haryana, and the one on the left is from Himachal Pradesh. This is just one page. Look at the amount of data that I gathered here versus what I showed on the previous one versus what you worked with yesterday. So I think there is room for improvement here in terms of the depth. And then the people will ask, the police will ask, it's taking me so much time, why do you need all of this data? We need to inform them, educate them that, okay, there are not necessarily for you, maybe there are other things that pertain to the infrastructure, to the operations, ultimately on safety. And here are two examples of FIR. One example, it's a 2-page document that it is from here Guwahati that Professor Maurya shared with me. Once again, the level of depth is limited. In 2 pages, you can see there are probably about 15 questions, 16 fields. And later on, I'll show you the FARS data, the second data set for a fatal accident reporting system, the depth of fields that we have. So come on. So we've talked about law enforcement. What we haven't talked about, infrastructure owners, these are public works agencies, municipalities, State Department of Transportation, who own and operate the roadways or public transit. They have sensors, they have other ways to gather data. It may be just how many lanes do you have, where do you have a stop sign, where do you have a traffic control sign, where do you have median barriers, And Professor Maurya showed several examples of things that are good, things that are not good. That comes from the infrastructure owners and operators, or maybe consultants or contractors who are going out. If you look at a Google Earth or Google Maps, you can see a lot of that right now. So that's the change from the old legacy systems to what are emerging. OEMs, original equipment manufacturers. So today's motor vehicle has so much instrumentation in it, so many sensors. Every month, so many manufacturers, especially of vehicles that have been sold, newly manufactured since 2013, 2014, have so much data. They send you every month your odometer reading, tachometer is this much. You have driven so many kilometers since your last oil change. Here are your tire pressures. Just simple. Same way, they maintain a lot more. Can we get that? And there is a OBD port, onboard diagnostics port, in most newer vehicles, which, if needed, a police officer with appropriate authority can read off data from. This has a lot of information in terms of the speed profile, acceleration profile, deceleration profile, so on. Now, newer cars, especially in the US, have other we refer to as ADAS, driver assist systems, including cameras mounted on the rear view mirror. That's tracking your eyeballs. There are sensors that are tracking how steady you're holding your steering. How is your speed profile, acceleration profile? Are you within the lane? There are cameras or sensors that detect how well you're keeping in the lane. Or if you stray away, you get either an audible or tactile or vibration saying you're straying. They're gathering this, they're using this for their analysis, and sometimes if you subscribe, you can get feedback. Can we look at partnerships with such companies to do? Eyeball tracking and the others are, especially on long distance drives, and if the computers in the vehicle detect that you are not as steady, time for a coffee break. It shows up a simple sign there. Why can't we do this for other safety related things? Yes, the intent is to improve safety, but how can we collaborate with it? Tire pressures being off is itself an issue for safety in many ways, especially if you have poor pavement conditions or adverse pavement conditions. And from the pavement tire interactions, we can discern a lot more about what's happening on the roadway. Friction, skidding, roadway conditions, rut, and so from a pavement design, not necessarily from safety, but there are some of those things that affect safety too. Bicyclists, this is a very, I don't know in India, Professor Maurya, you may have information, I don't know, but in the United States, there are many people who bicycle on a daily basis to commute, or they do this for recreational purposes. They ride for recreation 30, 40, 50 kilometers, but commute is maybe from 1 kilometer to 5 to 10 kilometers. They have little apps that they put on their phone that tracks their path, that tracks their speed, acceleration. It also tracks how much of displacement do you have in the vertical. There are accelerometers in your phone, and they share this with broadly other. And then if there are incident safety issues, they log it right there. So bicyclists then provide information to the planners, to the engineers, to the operators, saying, hey, we are seeing some issues in this. Are there apps like that in India?
We have apps like where people use to track, but not from this displacement. Mostly it is like how much you travel.
Yeah.
Like what path. Basically, you consider. So all those information that apps generally consider, like so maybe you can see that
travel
like
path, travel speed.
Yeah, travel speed. So in a way, like it's like it track your habit.
Okay.
Not from engineering perspective.
Yeah, and they use it for marketing too. As you're riding, okay, there's a Starbucks here. Do you want to stop? Or here's a sandwich store. Or here's so on and so forth. Okay, but same thing for beyond bicyclists. There's another group of advocates, wheelchair-bound users. They mount that on the either in their own thing when they are sitting or on the seat, and that measure gives you so much detail about the condition. We don't usually think about wheelchair-bound users because we seldom are in that position. But it's amazing to see the rich data that they are able to generate. So if we want to tap into that, that's more for planning, design and operations, but there are implications for safety too. We can look at how often do these paths get used by such people, and if you need to provide appropriate signal crossing time for them, they will need more time than others. Or can you detect a wheelchair bound user and give an extra amount of time when you have the presence of a wheelchair bound user? So cameras give them. And we talked about privacy. So this is a screenshot of one of the Uber rides that I took. After the ride, I get a message on my app saying, here's the receipt. This is where your trip started, exact location, address. This is where your trip ended. You paid for this with the credit card that ends with 8796. So this is the amount. And the whole thing. Everybody has this. Why are we so concerned about privacy? And Uber is using this so much. So in the United States and in the West, there's a much greater concern about privacy, but I think people are giving away a lot more about themselves. Whenever you use, here you have your automatic payment with your mobile phone. So you're giving away your location when you do that UPI, where you were, at what time you were. When I use my credit card, the credit card companies are tracking that. So when I use my credit card here, I got a message saying that, is this a fraudulent thing? You don't use your credit card in Guwahati in India. We see such a thing. Within seconds, I get that message. So I do not personally feel that this concern about privacy is as deeply, as sound as people make it to be. Then safety and risk. Insurance companies have a ton of data when people file claims. When, where, what, and they do lots of investigations, way more than we do as engineers. Can we look at economic and is there a concept of credit scores here in India now? Yes. For you to get a loan, so on. Yeah. Oh.
That is called CIBIL score, CIBIL.
Okay.
Yeah.
And so those are great indicators. There's a study that was done about 10 years ago. I had a small part in a related. The average credit scores, the mean, median, and the percentiles, deciles, are very good indicators of potential safety, adverse safety outcomes. People with poorer credit scores, or areas that have populations with lower credit scores, tend to have higher adverse safety outcomes. Just think about it as behavioral. If you're not a good person in terms of managing your own credit, chances are you're going to take risks in the transport field too. There are correlations. I don't say it is causal. The study shows some correlations between that. Insurance agencies use that. So if you live in this PIN code, your insurance premium is different from if you live in a different PIN code. These are all sources of data that we don't think about. That's what I started early on saying, what are non-traditional sources of data? We may use it for different purposes, for planning, for design, for operations, but a lot of that has a bearing on safety and legal. So from a mechanical perspective, there are lots and lots of vehicle related ones. I'm running a little short on time, but I'll keep going. Akhilesh, I may need more than 11:15, but let me see. So we talked about KBIS and ACES. So now I added two more S's, shared and safe systems.
Yeah. This, maybe we can break for
break and then come back.
Then come back and continue.
Yeah,
because
I'll
next
find
lecture
a, I'll find a
Yeah.
place to stop. So here we have sensor systems. How do we pull together the data? Or if the chai is already there, I don't want to go too long. Mobile phones and data aggregators. So other than government agencies or transport academicians, researchers, there are lots and lots of companies that aggregate data from third-party sources. They don't own the sensors, they don't own the infrastructure, but they tap into the data to come up with this. So here's another photo of the same. So moving on, when we have data from so many sources, the next challenge is from a technology side, we have the opportunities from various sensors. We talked about the spatial and temporal resolution. How do you capture it? How do you integrate it? And telemetry, you're communicating it from the sensor to where you need to process it. Now from an efficiency perspective, each of us has a personal goal. What we want is efficient, like several people said. I want to get to my destination as quickly as possible. Societal, it is overall movement of all the people and all the goods, not necessarily one person. Maybe if you are the chief minister, governor or prime minister, you have all the roads closed and you can travel at a speed that you want. If you, those of you who are familiar with the highway capacity, speed, flow, density curves, at low speeds, at high speeds you have very low volume, right. Flow is a product of speed and density. So when the speed is very high, density is close to 0. So each of us wants to travel as fast as we want, but what happens to the roadway? The capacity is very, very close to 0, the flow is 0. Whereas if you decrease the speed a little, density increases, and as a result flow increases. So what is personally optimal for me would have been to travel at 100 kilometers an hour, but what is best for all of us is maybe travel at 50 kilometers an hour, half of the free flow speed, you have the maximum capacity. Same way from a safety thing, what is best for me, for you, is not necessarily best for everybody. So that's the trade-off that we need to look, and not just for moving people, we need to look at the movement of freight. Most of us tend to just focus on moving people, but it's on the same roadways that we move freight. There are some areas such as the National Capital Region, from what I understand, the trucks or lorries are not allowed to come in during certain hours of the day to minimize the freight versus passenger movement. But from a safety perspective, separating those also has benefits, as we talked about yesterday. The heavy vehicles profiles and safety outcomes are different from. So from the CAVIS and the ACES areas, we can automate a lot of the data capture, processing and analysis, but the concerns are safety, security, we have talked about it, but vulnerability. Can intruders tap into this? When they tap into it, they can get the data, that is one concern. Just as big a concern or bigger concern is, can they manipulate once they gain access? It's just like somebody hacks into your phone or somebody hacks into your computer, they take control of it and can do what they want. So bad actors can do things. So how do we harden it? So for that, while we may be civil engineers, we need to work with cyber security specialists, computer engineers, communications people to help us achieve our goals. We may not have the domain expertise, but they bring the domain expertise, that collectively we work. And resiliency, if something goes down, the more we do things, the more we get used to it. We talked about being creatures of habits or getting used to things. So that ties in with the last one, is complacency. Complacency is, okay, I've done this, I say chalega, and paying, that causes a lack of attention as things move. We become complacent, we take it for granted. Agar speed cruise control pe dal do, so it is going to continue, but if there is a system malfunction, we are ill equipped then to take over. So that goes with the resiliency too. If that's the case, something goes down, everything is going to be havoc. So how do we prepare for those? So those are challenges with integrating data from different sources. And as we move from what I call legacies, what we have without the connected automated vehicles, types of vehicles we have had over the last 30 years, maybe the last 5 years we've had more connected vehicles in place. It will take another 15 to 20 years at a minimum for the vehicles that were purchased last year to roll off. And I know many of you talked about the vehicle scrappage program. Unless we have such a program to accelerate this, we are not going to be able to take advantage of the technologies or benefits, safety benefits offered. So we have to plan for a world where over time, over the next 15 years, 20 years, 30 years, something thereabout, we will have a mix of legacy vehicles and the connected automated vehicles. That mix likely will go up, it's going to be slow, the adoption is going to be slow, and then it will accelerate. If we look at technologies, the history of technology, but we have to be ready as transportation folks, how do we work to facilitate that? So here's a photo that I took in Las Vegas of various types of cameras and sensors on a roadside equipment. They provide us information on traffic operations, signal conditions, signal operations, speed, flow, volume, pedestrians, bicyclists, so on. I talked about the vehicle, the scale and size, local versus edge computing. I got ahead of myself a few minutes back. We don't necessarily need to transmit all the data that we are collecting to a central area. We could do local processing. That's what is the local or edge computing. And not all of the data that we gather needs to be sent to a central place. And even if it is sent to a central place, we use it for a few minutes, maybe an hour, and we can dump it. We don't need to continuously store it. There are some that we need to keep, some that we don't need to. And then how do you communicate? Wireless communications are probably less capital intensive, but have their own limitations in terms of bandwidth, volumes that you can transfer. Whereas if you use fiber optics or wired connections, that's more capital intensive. You need to spend a lot more money to put that. And the disruption, whether you dig trenches to put this or do overhead, there's going to be other disruption. And there are protocols and standards, again coming from IEEE and Association of Computing, ACM Computing Machinists, that talk about how to compress the data and be more efficient about those transfers, safety and security of these transfers. The point I'm making is, don't think that we can do it ourselves. We need to work with others from other domains. So here are the technologies and the applications. So real-time traffic monitoring, we just need data for short periods of time, maybe minutes. Incident detection, once again, maybe an hour if you have a major incident that will cause disruptions on highways. Variable speed limits, I've mentioned this several times. Depending upon the prevailing conditions, whether it is weather, traffic flow, so on, you can change the posted speed limit. Again, you're talking about duration of minutes, not days. And dynamic lane management in several parts. The central lane may be operating going in one direction in the morning and the opposite direction in the afternoon. So because if you have unbalanced traffic flows, we don't have enough space right of way to build more lanes. Whatever lanes we have, we are going to use it more effectively. So for that, once again, we need data for maybe minutes to hours, not for years. And what I understand is in India, there are movements, and I will leave it to Professor Maurya and Dr. Bhardwaj to talk about more of these. But there is movement in this domain. And I've participated in several events over the last 4 or 5 years that lead me to believe that it's rapidly gaining traction or adoption, but it is expensive. And it more or less, a lot of the tools and sensors are being deployed either on this high speed expressways, limited access, or by companies that own a fleet of trucks who want to manage their freight operations, and to a limited extent on public transit facilities. Yeah, I've talked about this. I'll just let you read it for a few seconds. Just examples of where these are used. So the driver's license is an official record. It has a whole bunch of information, but the key that we need is what I have in red, that is the unique ID number. That's what we are going to use to connect to look at repeat offenders, repeat violators. Other information is relevant, for example, their address or their PIN code of residence if you're trying to look at safety with respect to where they live or where they work. But one key thing is the driver's license number, which is unique to every individual. But it may be a combination of a state and the driver's license number. Maybe the same number is repeated in another state. But there is a way to uniquely identify everyone. And driver's licenses, as we mentioned yesterday, you have different for light vehicles, two-wheelers, motor cars, buses, trucks, so on. Again, there are issues related to the storage and maintenance, confidentiality of the data. And I understand that there are newer platforms such as Sarathi and Vahan systems that will allow you as a user to manage some of the information, and the agencies, the RTOs or others, motor vehicle agencies, to maintain that too. What I just heard on this trip is that you can link your driver's license to any motor vehicle that you have owned and that you have registered. Does anybody have experience with that? Okay, Ritvik, you're saying yes? Ritvik, were you saying yes? Yes. Okay, thank you. And globally too, there are some examples, best practices. The big concern once again comes to hacking. If somebody gets access to these records, what could it do? In safety analysis, we use it from the police and identify repeat violators, offenders, and compliance. If working with the courts, the judges, to make sure that the same person who had issues in state A is not coming to state B and say, oh, I'm a clean person. And then we can identify high risk groups and whether provide incentives to improve their behavior or punitive. Punitive is typically insurance agencies use that. If you have more and more violations, we are going to increase the premium that you have to pay. And after a certain point, some companies say, no, I'm not going to insure you because you are a higher risk than we can bear. And road safety campaigns, if we have issues in certain areas, certain communities, certain types of users, you all talked about auto rickshaw drivers, taxi drivers, so on and so forth. Is that a group, and based upon the driver's licenses, we can tie them together? How do we interact with them, work with them? And here the electronic driver's license tied to electronic challans or citations will help us near real time. I hesitate to use real time because there's always some delay. It may be minutes, it may be hours, but probably within a day. If you have this challan system, e-challans is what I understand, and this electronic driver's licenses, we can tie a lot of these things together in near real time. It will facilitate not only intrastate, let's say within Assam, within Nagaland, within West Bengal, within Uttar Pradesh, but across states. But for that we need more of a centralized coordination, not just within the state, within the districts, but go beyond that. That may not be instantaneous near real time. It may be every 24 hours everything is synced up at midnight every day or 1 a.m. or so on and so forth. But still that is good enough for most of the purposes that we are looking at. There's other criminal things where you may have somebody who is a violent offender who is walking around with a gun. Then you want to know it by the minute. Was that person in district A, moved to district B, going to another state? But for our traffic safety, we don't need it by the minute. So we have National Drivers Register. I mentioned that. I think I may have said National Drivers Registry yesterday. The technical term is National Drivers Register in the US. And there's a problem driver pointer system that the National Highway Traffic Safety Administration in the US has to try to identify people who have repeat violations and then share that across. We have 50 states in the US and a few territories, and share that. The insurance agencies share it across themselves, but they are so privately guarded, it's very hard to tap into that unless we can show them that the analysis we will do will benefit them. What's in it for me? And they are also concerned about compromising safety of their customers or security, the data privacy issues. The vehicle registration databases, likewise in the US, we have what is called a VIN, vehicle identifier number. That's a 16-digit code unique to every vehicle. And the way it is structured is it shows where the vehicle was assembled or manufactured, who is the company, is it Toyota, Hyundai, Mahindra, so on and so forth. What is the model and what is the make within the model? You may have some variations and so on and so forth, and including safety features. Based upon the make and model and their attributes, you can know whether this car or this bus had such and such safety features. So here are several applications. Once again, we are looking at emerging tools and technologies such as data mining, data integration, artificial intelligence applications to try to transform what we are getting as data to information, to knowledge, to actionable decision. What used to take months or years, I think we can do it in minutes or days. if we have the right set of linkages and get the right set of data. So mobile phone, we've talked quite a bit about this. I jumped ahead, and there are plenty of examples. Of what I want to look at is B, the examples. There are rules and regulations, laws and regulations aimed to protect the privacy of the users. Many of us, when we buy a phone or we activate a phone, there's a lot of legal thing. Do you accept? Do you accept? I don't know how many people, maybe less than 1/10 of 1% of the population actually reads through all of that. Companies, if organization buys a cell phone and gives it to their employees, I suspect that they have some legal team that is looking at all of that and saying you should do this or you should not do this. But most of us do not pay close enough attention, and we are unwittingly saying, okay, we are sharing our data, willing to share our data with you. But in the European Union, they have more stringent protections saying that people need to opt in, as opposed to default is you're in, and then if you don't want to be a part of it, you opt out. So the counter, we should use the counter thing is, you're not in anything, but if you want to participate, you have to say, yes, I want to participate. That's a shift in mindset of how we go about doing things. And I believe the Indian Ministry of IT is looking along similar lines. I don't have first-hand information. This is what Sushma, my student, was able to find when she was helping me put these together. So connected vehicle technologies, there are many. Speed, location, time, speed, acceleration, and a whole bunch of data related to the vehicle performance. We talked about sudden braking, lateral, longitudinal. There are cameras, and I believe in India many people have their own cameras that they mount either on their helmets, in the car, just to say somebody accuses them of being involved in a crash, saying you are responsible, to show documentary evidence that. So that's aftermarket, but there are vehicles that have these camera systems that are just built in for the safety and security of the, but they also continuously record, and you could use that if necessary to reconstruct crashes. But my goal is to prevent crashes, not to reconstruct crashes, right? So how do we, there are things that are more reactive, but how can we leverage those for proactive? Event data recorders, the black boxes that we talked about. OBDs, ports where we can extract a whole bunch of data. Has any one of you worked with data collected from OBDs? Yes, oh great. So I have several people here. Maybe at some other time I'll ask you to talk about it. I'm just worried about the time. I need to give Professor Maurya enough time. So how can we use in-vehicle technologies? Some of the examples I used is to provide, whether you have LiDAR based or camera based systems in a vehicle that detect a potential pedestrian crossing the street, alert the motorist. If the motorist doesn't take action, the vehicle takes action. If the vehicle automatically brakes, but the vehicle also has sensors to see who is behind, so that you're not going to start a rear end collision. There's a lot that needs to go on to integrate all of these. So we have civil engineers, roadway engineers, transportation engineers, mechanical engineers, communications and controls, people from electrical engineering, so on, who all need to work together to bring to reality what are the possibilities that technologies afford. I won't dwell on this. This is something that I think we need to take into account. There are many V's. When you get the slides, you will see it, and if you have questions about that, don't take data for granted. Just because somebody says, here are some data, check, verify, validate that these data mean what you think they mean, or understand what they mean and use it appropriately, and security, vulnerability, so on. The big point that I wanted to make here are in the Las Vegas metropolitan area, what you see are traffic. Oh, I need to activate the. Each one of these symbols is a camera. So we have, I told you, more than 1,500 intersections. A vast majority of them have cameras. How do we get data? The biggest concerns, what I wanted to look at, is who has access to the data, at what level of access, what level of detail, and when. Some people may have only access for the 2 minutes or 3 minutes that they are operating the traffic signal. Others may need it for a longer period of time. Once again, these are driven by cost concerns. Legal, in the US, the legal concerns are huge. If you break the law wittingly or unwittingly, or as an employee of an organization, did something that somebody else challenges, a user, a citizen says, you gave away or you took my license plate information and my photo, you shouldn't have done that. You can be charged in a court of law and could lead to civil penalties. Unless it is something intentional, there are no criminal penalties. So we've talked about why we need to tie data together over the last day and a half. Right. So the overcoming barriers is lack of compatibility of data, compatibility on a spatial scale, on a temporal scale. One data stream is coming in every second, another data stream is coming in every 5 minutes. How do you piece it together? Unless you have, whether you have an API that you write to say, okay, I'm going to aggregate it and take the mean, or I'm going to take the median, or I'm going to take some statistical measure of that, what I get every second, so that I can map it with the 5 minutes. So those are some of the privacy concerns. Lack of coordination. Okay, I'm going to report my day is from 8 a.m. to 7:59 a.m. next day. So every day thing that I'm reporting is a. His company says no, I want it from 12 noon to 11:59 a.m. Your company says no, it should be midnight to 11:59 p.m. So the definition of a day, each of us has 24 hours of data, but the definition changes, right? So we need to make sure that we are coordinated. I'm using a very crude, simple example to illustrate it, but it gets more complicated. How do we improve the data quality? How do we enhance the analysis? One is to verify the quality, but to speed up the analysis. When we are getting much more volumes of data, we can't wait 1 year, 2 years, 3 years to analyze the data. Can we do it in minutes or hours? So that's where the computing tools and technologies, and determining what data you need for your actual analysis. Just because I get every second or every minute, I don't need to do that. I can aggregate it per hour, so that reduces the complexity, the volume of the data. And safety. It's a core value, right? Not a priority. I repeat, safety should not be a priority, it should be a core value. And look at how do you leverage data from multiple sources. These are what I know of now. There will be new data sources that come. Be ready to adopt or adapt them as necessary. Be sure that you are informed about emerging technologies, advancements in hardware, software, communications. You don't have to be an expert, but just know that there's something's happening. Be intelligent enough to have a meaningful conversation, engage the right experts to help you do those analysis. Teamwork and communication. So none of us can do much individually, but joining with each other, the same disciplines, or joining across disciplines, we can make much bigger differences. And I want to say, click it every trip, every position, before you start the engine to after you stop the engine. I went over quite a bit more than what I had anticipated. Let's see, where's Professor Maurya? Can one of you look for Professor Maurya?
I have one question.
Yes, Ritvik.
Sir, how to make this seatbelt be a default for back seaters? Because that's becoming a. I mean, why should I wear it on the back seat?
Why should you wear it on the back seat?
I know you did explain about the projectile and all that, but I can't explain it to my near and dear ones.
Okay.
It'll look funny, right?
Look for a few of these video clips. Have that on your phone. Just show it to them. And for most people's rational discussions may not cut it, saying here are data, here's a scientific analysis, so on and so forth. So the rational discussions will not necessarily say. Then you got to go emotional. what will tug at their hearts, what will make a difference. Or point to examples that you know of from your community, from your neighborhoods, where such sad events have occurred, which could have been prevented had the occupants been wearing seatbelts. Other than that, it's very hard to bring about a change.
Yeah, thank you, sir.
Sir,
Yes.
why we don't focus or use satellite data for traffic improve safety?
Uh,
As we use satellite data for maritime prediction, aviation industry, for disaster mitigation.
I'm not as well informed in that domain. We use satellite technology to track vehicles of interest, more so from a military perspective. We can get down to one bicycle that is moving. Okay, we can read a license plate from, but I think there are more efficient and effective tools and technologies that are terrain based than having to go to the satellite. Just think about the cost that it takes to do that. But if those data are available, how might you leverage that as opposed to sending up a satellite just for this? Again, that's not an area where I have done a lot of work. So this is my, let's say, my reflections or thinking of why we are not doing that. All right.
Hello, sir.
Yes, question online.
Yes, sir. So can I ask?
Tazim, I have you.
Yes, am I audible?
Yes.
Sir, basically my question revolves one of the basic things. Can you give me crisp data points or crisp briefing about how can, being a transportation engineers, how can we optimize the trade-off between the safety and LOS, which is directly related to travel time or delays, as they seem to be inversely proportional to each other?
Yeah, there are lots and lots of data that point to one is the operating speed when a crash occurred and its outcome. So what you see are that at higher speeds you have much worse outcomes than at lower speeds. So that's something we've seen in the last 2 days. But when it comes to level of safety, the example I gave about 10 minutes ago, at when somebody wants to operate a vehicle at 100 kilometers an hour, the density likely is going to be very low. So the flow that you are facilitating is going to be very low because flow is a product of speed and density. Whereas you drop the operating speed or the posted speed limit to 50 kilometers an hour, density goes up, and then the overall capacity increases. So you need to pair them side by side, speed versus safety outcomes, speed versus capacity. In both cases, when you drop the speed, the safety outcomes improve. When you drop the speed, your capacity improves. Does that answer your question?
Exactly. So that was my point. How can we trade off between these two? I mean, when we try a line or when we improve the lanes for cyclists, it improves safety but reduces capacity. Similarly, raised crosswalks reduce pedestrian fatalities but increases vehicular delays.
Yeah, as I said earlier, safety is not a priority. I'm not going to compromise on that. It is a core value. It's not a priority. If it is important to society, we need to have people understand that they need to be willing to compromise on other aspects and not on safety. And it will take a movement. Just as I mentioned in today's lecture, how did India go in a short span of 5 to 10 years where tobacco use, smoking in public spaces is unacceptable? A vast majority of the society now subscribes to that and enforces that. Why can't we do the same thing for safety, whether it is using seat belts, making sure that all your hazard lights, your blinkers are working, your headlights are working, your tail lights are working. So Tazim, I don't have a simple answer to that. It has to be a movement, a collective effort.
Okay, thanks. Sir.
Anybody else?
Thank you, sir.
You're welcome.
Hello, sir.
Yeah, Krishna Kishore.
Sir, you talked about a unique ID number, sir, for a data integration.
Yes.
Would like other you are saying, sir, in India, kind of thing would help.
Please repeat your question. What about the unique ID?
Sir, you said unique ID is needed for data integration and for using the data across multiple agencies, right?
Yes.
License record, registration,
yes.
police FIRs.
Yes.
So could be Aadhaar be useful, Aadhaar card number be useful
yeah,
in India?
it certainly could be, but I'm not well versed in what the limitations of the Aadhaar card are. Are there government policies that limit when and where you can use Aadhaar card as a point of reference? There are many other ways. I don't know if your Aadhaar card is linked to your driver's licenses here. So, but there you
Yes, sir,
must
it's
have,
linked in
yeah,
Maharashtra.
yeah, and there are other ways
Yes,
to
yes.
other ways that we can, even if you do not have a unique ID, there are surrogate ways. For example, if you knew that a fatal crash occurred at 11:48 a.m. at such and such an intersection or such and such a location, there were 2 vehicles involved, 1 fatality, so on, and you don't have details, but then you can look at the hospitals around and say, okay, at 12:15 there were 2 crash victims who were brought. So now that is more of a deductive or detective work that you have to do. You didn't have a unique ID in terms of the Aadhaar card number of the person who was injured versus the Aadhaar card number of the person who went into the hospital. So if you have a unique ID, it makes life a lot easier. If you don't have a unique ID, you have to do some detective and deductive work. All right.